All right, so in the trig table, one, I have added the sum and difference formulas so that they're all on one page. But our notes are actually right there under 3.5. I'm not going to go over these exactly because I don't feel like it's all necessary. This is a discovery on how, so it's the proof of. So if you want to Google for fun to watch the proof of these formulas, what it does is basically tell you that these formulas are not just made up, that they work because of the trig that we already know. You don't necessarily have to know how to do the proof, so that's going to be an on your own if you want to do it type thing. But here, so the boxes are all the formulas. So there's the cosine ones. Go on down. Here are the sine ones. And then the tangent, which once you learn one, the other one works the same way for sine and cosine. Tangent's a little harder because you got fractions upon fractions. So you got complex fractions, but it's still not bad. Degrees are definitely the easiest just because our brain comprehends integers better than fractions. And when they're in radians, it ends up being fractions. Okay, so if we want to find the exact value of cosine 15, here's what that means. If I go to Desmos and type in cosine of 15 and I make sure that I'm in degrees, it's going to give me an irrational number, meaning a crazy decimal. That's not what this question is wanting. So please don't give me those type of answers on the quiz or on your homework or whatever. If it says exact value, that's where it wants the square root. Okay. So we can use, try to get this more comfortable for me. One of these formulas. So remember, we know all of the sine and cosine values for all the numbers on the unit circle. Okay, so think about all the degrees on the unit circle. Are there two of those numbers that I could add or subtract and get 15? So all of these degrees here on that list, those are all the degrees that show up on the unit circle. What two numbers could I add or subtract together? So put a plus sign or a minus sign between them and get 15. There's more than one answer. I usually like to do the smallest though, but it really doesn't matter. So what is 45 minus 30? Isn't that 15? So I could say that this would be 15, right? And so it is subtraction, so I'm going to use this one right here. So cosine 45 minus 30 equals cosine 45 times cosine 30 plus sine 45 sine 30. Okay, so I took that directly from the second line there. and I am going to use the unit circle. So what is cosine 45 degrees? If you're not sure, you go back up to the table. Sine and cosine of 45 degrees are both square root of 2 over 2. Cosine of 30 is square root of 3 over 2, and then sine is 1/2, so that I don't have to keep switching back and forth. So square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2. Okay. Order of operations says I need to do the multiplication, so that's square root of 6 over 4 plus square root of 2 over 4. That's a common denominator, so it's all over 4. And you may be tempted to reduce because it's all even numbers, but remember, something under the radical and something outside of the radical you cannot reduce. So this is the exact value. And if it were me and I'm taking the test, so it's test day or quiz day, and I'm trying to make sure that like I've got it right, whatever, then maybe what I do is open up Desmos and first do cosine of 15 degrees. Okay, there's my crazy decimal, right? Then maybe I put my answer. So square root 6 plus square root 2 all over 4. And they match. So that I know that I've done it correctly. Like I know I haven't made a simple algebra mistake because these two are equal. Okay. Now, it's a little easier on your homework because you just type it in and it tells you if it's right or wrong. And if it's wrong, you type it again. But this is what you can do to check your answer. So that would be good on like quiz testing. Okay. Questions on how that works. So cosine of, you would use the addition if the two numbers are adding. So really the hardest part is trying to think of the two numbers that would add or subtract to get the value it's asking for. So in this case, like what is cosine 15? If I want it, so like this one looks confusing, but really it's just the subtraction of cosine. So I would use that same formula where I would do cosine pi over 2 cosine theta plus sine pi over 2 sine theta. So pi over 2 is 90 degrees. So sine is 1 and cosine is 0. Well, 0 times anything is 0, and 1 times sine theta is just sine theta. These are just more proofs. Your homework / quiz / test is more straightforward, so I'm going to keep going with the straightforwards. So the sine formulas, they're a little different in order. but they work the same way. So then I say, find the exact value of sine of 19 pi over 12. Okay. A lot of us fractions are not our friends. So like if I'm trying to say what are two things that add together to get 19 pi over 12 or subtract, you may be stuck. You have a couple of options. You can just kind of struggle through it, do some guess and checks. Your other option would be to go ahead and turn that into degrees. My pen is not working well today. So that's 285 degrees. So what are two things that either add or subtract to get 285 degrees? They're actually next to each other in the degree column that add together to get 285.
$135 and $150.
Mm-hmm. Okay, so those are the radians of that, right? So when I write this, I should keep it in the same format. So sine of, and I'm going to be adding, so order doesn't really matter. If it were subtraction, order does matter. And so for adding, it's sines cosine plus cosine times sine. So to check yourself, just make sure that you didn't do any of them twice. Like you should have the sine and cosine used once for each radian. Okay. Sine is positive because it's in the second quadrant. Cosine is negative because it's in the second quadrant. Okay. So here I get negative square root of 6 over 4 minus square root of 2 over 4. All right. And then there's tangent. Tangent just stinks because you're going to be dealing with fractions over fractions, and you got to remember your fraction rules. And I know how much we all love fractions, right? But otherwise, it's really not that bad. Not the funnest, but not bad. It's also not bad when you have your trig table right here that tells you all the values, right? So for this one, I have subtraction, so I'm going to use this one. I need to know what tangent of 2 pi is. And then in this case, I'm just leaving it tangent theta, so I don't have to worry about that. So what is tangent of 2 pi? Well, 2 pi is 0. And tangent is y divided by x. So at 1, 0, so it'd be 0, right? This one will be all right then. So 0 minus tangent theta over 1 plus 0 times tangent theta. These are going to cancel. It's going to leave me with negative tangent theta over 1, which is just negative tangent theta. Trying to see if there's one like all right, let's look at your homework before I decide to go over those others or not, because I don't want to waste your time. All right, so if I have something like this, I'm using the formula to see which one that is. So like if I have sine cosine plus cosine sine, which one is that? Is that sine or cosine? And you might not have that memorized, but do you know where to find that? Do you know to go? And I can't remember if I have the flipped on or whatever, but like here in our notebook, right? So which ones? So notice that it is sine that has sine, cosine plus cosine sine. It's also the sine. If it's an addition sign, you add the degrees. So what is 70 plus 30? That's 100. So you're using that formula to kind of work backwards. That makes sense. That's pretty much just like the one we did with 285. Okay, tangent 15. That one will not be super fun. We'll go over that one. That's what I wanted to see if they gave you a regular one. So this one, they kind of went the other way. So you're like, oh no, 5 pi over 12 is not on the unit circle. I don't know what to do. But if you look at the formula there, it's sine, cosine, cosine, sine. So that means that it's a sine one with a minus in between. So that means I'm going to subtract the 2. So if I subtract I get negative pi over 3. So what is sine of negative pi over 3? It's going to be negative 1/2. So you're just using your unit circle to work backwards on that one. So what I did, 5 pi over 12 minus 3 pi over 4 is negative pi over 3. So this is really asking what is sine of negative pi over 3, which equal, like that's not how you're typing that in, but I'm showing you how you find that answer. All right, so for these, you're already given the part of the answers. So like when you're thinking about this being sine alpha cosine beta, and then you would have plus cosine alpha sine. Okay, I know that's incorrect. Sorry, I didn't mean to hit enter. Well, sine alpha is 5/13. Cosine beta is 8 square root 145 over 145. But what you don't have is the next part. Like, do you know what cosine is? Well, no, but can you easily find it? So think about, I have a chat, hold on. So think about sine, nope, I thought I hit annotate, there we go. If sine is opposite over hypotenuse, how do I find the adjacent?
Pythagorean theorem.
Mm-hmm. So 1, 2, skip a few, x equals 12, or x equals 12. So then cosine alpha would equal 12 over 13. Does that make sense? Because it's adjacent over hypotenuse. Okay. And then I would have to do the same thing here. So cosine is adjacent over hypotenuse. Notice that that's just 8 over square root of 45 rationalized. There should be a 5 there. So 145, I'm out of space there. So x squared equals 81, which means x equals 9. So now for sine of that, 9 over square root of 145, or and then I would simplify from there, just algebra, to get a nicer number there. Okay. So really for your answer, you're just typing the number, not all that. And that's the same idea, same idea. We did one like that. That was where we got something real simple. Okay, so the last one I want to show you is a tangent problem, and then I'll let you go, okay? I'm just going to go down here at the bottom. So if I'm doing tangent of 15 degrees, we already talked about earlier, we can use 45 minus 30 as our two, whatever. And then I'll zoom that back in. I'm just going up here to okay. Making sure I had it memorized. I haven't used it in a year, so don't want to screw that part up. All right, so we're going to call this one alpha and this one beta. So we're going to have tangent of 45 degrees minus tangent of 30 degrees all over 1 plus tangent 45 times tangent 30. So if you need to take a second, look at your trig table. All right, tangent of 30 is square root of 3 over 3. Tangent of 45 is 1. Okay, if we could leave our answer like that, everything would be golden, but we can't. So we want to multiply by the conjugate. Can't remember if this is the shortest way. So sorry if we take the longer route. All right. What happens then is I do first times first is 1. The outer and the inners cancel when I multiply those out. So I do last times last to get square root of 3 times square root of 3 is 3 over 3 times 3 is 9. In the top, I'm going to get 1 minus 2 square root of 3 over 3 plus 3/9. Yeah, this probably wasn't the quicker way, but that's okay. We'll keep going. Okay. So remember, 1 is the same thing as 9 over 9 if I'm trying to do common denominators. So in the top, I get 9 plus 3 is 12 over 9. Yes, I can reduce that. Feel free to. I'll do it eventually. Algebra says 9 minus 3 is 6/9. I'll go ahead and reduce those to make life easier. Okay. If you think about this in terms of fractions, so 4/3 minus 2 square root of 3, well, actually, let's go ahead and combine that. They have the same, the top has the same denominator, it's all over 3. Divided by 2/3, right? So, multiply by the reciprocal. Cancel, cancel. And I'm left with this, which reduces one more time. All that work for this tiny answer. Okay. So I'm going to go up here and say, that way if you look back at it, you see this. Multiply by conjugate. Which means to change the inside sign. So like this was a positive, we changed it to a negative. And then we multiplied. And then from here we simplified. And then here is divide fractions, which means to multiply by reciprocal. And then reduce. That way, if you go back and look at this, the steps are there for you. And you can find this at the very bottom of the 3-5 notes. So like it's not part of the pages, but I did it at the bottom. So tangent is the suckiest, but notice it's not because of using the formula was hard, because that part was easy. Here's the formula. I just plug in the numbers. Cool. What sucked was the algebra to simplify it. Okay, that's the part that's not fun, is the algebra to simplify it. But what you're doing isn't too bad.